Okay, so today we're going to talk about graphing logarithmic functions, and then we're going to do transformations with those functions. Remember that your calculator only does base 10 and base e functions. And so when we have a function like this, log base 3, then we need to really create our own set of points. So if you're pretty good with logs, you may not need to rearrange it, but I'm going to show you how you can rearrange this and create a set of points that you could switch x and y for. So if we put this back into exponential form, it would be 3 to the y power equals x. And so if I make me a table of values here, instead of choosing for x, I'm going to choose for y. -1, 0, 1, 2. And so when I choose for y, 3 to the -1 power is 1/3. 3 to the 0 power is 1. 3 to the first power is 3. 3 to the second power is 9. And that gives us some points on our graph. So we have 1/3, -1, 1, 0, 3, 1, and then 9, 2. Okay, so if you want to rearrange it so that you can pick some numbers for y, that does make it pretty easy to get the sketch of the parent function graph. So depending on what base you have, of course those numbers will change up a little bit, but it's probably easiest to use for your parent -1, 0, 1, and 2 for your y values. Okay, so now we're just going to use that equation, that graph, to make some changes, some transformations, just like we have for every other function. All right, so our first example, it says write the equation to shift the graph up 2 and left 1. So we're going to have f of x or y equals, and then we have log base 3, that identifies our parent function, of, and our left right shift is going to go inside. Remember, it's the opposite of what you think, so it's x plus 1, and then up 2 would be plus 2 on the end. As far as the table of values goes, if you want to make changes to our table up there, then we're going to be subtracting 1 from the x's and adding 2 to the y's. So I have 1/3 minus 1 would be -2/3. 1 minus 1, 0. 3 minus 1, 2. And 9 minus 1, 8. And then adding 2, -1 plus 2 would be 1, 0 plus 2, 2, 1 plus 2, 3, and 2 plus 2, 4. So this would give us a new set of points that we can sketch. And so we have -2/3, 1, 0, 2, 2, 3, and then 8, 4. So our graph moves up. Now remember that there is an asymptote involved here. This graph does keep going towards this line, but it never crosses it. So back up here, I probably should have pointed that out. This y-axis is your asymptote. This graph keeps going in both directions, just like the exponential function kept going and never crossed the x-axis. This never crosses the y-axis, so we have a vertical asymptote there. So since we shifted left 1, our vertical asymptote is at x equals 1. All right, next it wants us to write the equation to reflect the graph across the x-axis. So if we're going to go across the x-axis, we need to change the y's. And to change the y, we just put a negative in front. In our table, we would actually just change the y value, so our x's would stay the same. Our y's would be +1, 0, -1, and -2. And that would be our points to graph. So we have 1/3 +1, 1, 0, 3, -1, and 9, -2. So our graph just flips over the y-axis. Sorry, the x-axis. All right, on the back, They want us to use that same equation to reflect across the y-axis, which means we need to change our x's. And so if I'm changing my x's, then it's going to be y, or f of x, equals log base 3 of negative x. We actually change the x in the equation. We're also going to change our x's in our chart. So we have negative, I forgot what the word, 1/3, 1, 3, and 9. So negative 1/3, negative, oh my goodness, 1, negative 3, and negative 9. And our y values are going to stay the same. So we had negative 1, 0, 1, and 2. Phew, oh, excuse me. All right. So we have negative 1/3, negative 1, negative 1, 0, negative 3, 1, negative 9, 2, which makes our graph reflect across the y-axis. So all of the transformations that we have done for all other functions are applicable to the log function, the same as any other. So below we have some review problems, and then one that's a little bit different. So for number 4, we are going to, these are all log base A, so all the same logs. So we're going to combine some logs together, but I'm solving for x here. It really doesn't matter which side, since each of these logs has x, where we keep them. So I'm just going to combine them as they are. So we have log base A of x times x minus 2, because addition becomes multiplication, equals log base A of x plus 4. Since they are now both single logarithms with the same base, I can cross them out. So now I can distribute, and I have x squared minus 2x equals x plus 4. And then I can move it all to one side since it is quadratic. And I have x squared minus 3x minus 4 equals 0. And then I just factor. So I have x times x. To get 3 in the middle, I need to use 4 and 1 instead of 2 and 2. And negative 4 plus 1 would give me negative 3. So x is 4, or x is negative 1. But don't forget, we need to go back and check those solutions. The 4 looks like it would be fine, but the negative 1 we can't use because we can't take the log of a negative number. So only x equals 4. I apologize for my dogs, but they seem to be a little antsy right now. All right, so let's go ahead and finish these two out. For number 5, something that you'll notice is different that we haven't had before is that these log bases are not the same. So we can't combine logs if they are not the same. Therefore, we need to use the same base, and we can't go down from 3. So we're going to take this log 9 and change it to a log 3. So log base 3 of x over log base 3 of 9. That's the change of base formula right here. Plus 3 log base 3 of x equals 14. So right here we can solve, because 3 to what power gives me 9? That would just be 2. So this equals 2. So we'd have log base 3 of x over 2 plus 3 log base 3 of x equals 14. So if you don't want this 2 in the bottom, you could multiply through the entire equation by 2. So these would just cancel out, and I'd have log base 3 of x plus 6 log base 3 of x equals 28. And then I could bring this 6 over here as an exponent, and then when I add, I multiply. So I'd have log base 3 of x times x to the 6th equals 28. And so x times x to the 6th, the x to the 7th. Oh, sorry. And then I would go back and rearrange, because now I've got a single logarithm with a constant number, and I would just rearrange 3 to the 28th power equals x to the 7th power. Now, you could go ahead and multiply 3 to the 28th power on the calculator if you'd like. However, we're going to need to raise both sides to the reciprocal power, so the 1/7 power. And when I do that, I have x equals, and a power to a power I would multiply, so 28 over 7 is just 4. And 3 to the 4th power is 81. So if you run across a problem where the bases are not the same, you have to create equal bases before you can combine logarithms. So use the change of base formula, and then you can combine your logs and solve just algebraically. All right, then for number 6, our last example, we're just going to put the left side in y1, the right side in y2, sketch the graph, and find the intersection. All right, so I'll use that TI app. I guess you could use Desmos as well, but we have x plus e to the x power, and then 2 in y2. We're going to graph it, so I'm going to zoom 6 this and make sure it's a standard window. So this curve here is x plus e to the x. Here's 2. We want to find that intersection, so second, calculate 5, enter, 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 and I get x is 0.4428, so 0.443, comma 2. There it is, so you can see it. So we're going to make a sketch of this, and again, our sketches do not have to be super accurate. We have this curve coming in kind of straight, and then it goes up. We have this line come across here, and we found this point, which was at 0.443, comma 2. So x is 0.443. Now be careful, for some of these, there may be more than one intersection on the calculator. So if there's multiple intersections, find all of them. All right, so most of our work here is on graphing logarithmic functions. Remember that you can rearrange and then find your points. Once you have your parent function graph, the changes should be the same as what we've been doing for several units now. And then we have some review problems on the back. If you have separate bases, different bases, you need to get equal bases first.